Question 14 wants you to express 0.25 recurring as a fraction in its simplest form. Now, first thing you have to actually understand what that dot means. That means it's 0.2, and because the dot's only above the 5, it means that just the 5 is recurring. Okay, so that 5 will keep going on forever. Now, they want to express it as a fraction in its simplest form. What I need to do is to get rid of all those 5s that keep going. Because if I can get rid of the recurring 5, then I'm just left with integer numbers, and I can work with those and express them as a fraction. So I'm going to start by first of all making the statement that x is equal to 0.25 recurring. Now I can find out what 10x is equal to by simply timesing that by 10, which means the decimal would now be there. So you'd have 2.5 recurring. So that's good. I've got the 5 recurring after the decimal. However, I need to be able to now subtract them from each other to get rid of the recurring, which I can't do. So let's go up one more. Let's see what 100x would be. So 100x would be 1, 2. So it would be 25.5 recurring. Now I can see here I've ended up with the 5 recurring after the decimal point in both of these numbers. So if I do 100x, take away that 10x, that would give me 25.5 recurring. Take away 2.5 recurring, means the recurring would cancel out, leaving me with 25. Take away 2, which would give me 23. And because I did 100x take away 10x, that's actually equal to 90x. So now I've got 90x is equal to 23. I want to get x on its own, so I can divide by the 90 on both sides. And that leaves me with x is equal to 23 over 90. Now, they did want it as a fraction in its simplest form. 23 doesn't simplify down. I know you might think 3 goes into both of them because it ends in a 3, but it doesn't. So that is the fraction in its simplest form. With regards to how the marks are allocated, it's a 3-mark question. You get 1 mark for showing that you know what the recurring decimal actually means. You get a 2nd mark for 2 correct recurring decimals that when you take them away from each other would result in a terminating decimal or in an integer. So that's those 2. That's where my 2nd mark comes from. And then the 3rd mark is for getting the correct answer. Question 15 is about straight lines, gradients, perpendicular gradients, and equations of lines. So a straight line, L, is perpendicular to the line with the equation y equals 1 minus 3x. The point with coordinates 6, 3 is on the line L. Find an equation of the line L. Well, first thing I'm going to just remind myself is that coordinates are always written as an x value, comma, y value. And then I'm also going to remind myself that we're dealing with straight lines here, and the fact they've mentioned perpendicular, or it might be about parallel. Either way, they should make you be thinking about the equation of a straight line, which is y equals mx plus c, where y and x are the y and x axes, and m is the gradient, and c is the y-axis intercept. So y equals mx plus c. Anytime I've got a straight line, I always want it in that format. Now they've given me an equation here, y equals 1 minus 3x. Well, I actually want whatever the x term is, I want it first. So I'm going to rewrite that as y equals minus 3x, and that's a positive 1. Now I've not changed anything, I've just written it in the way I want it. Some of you may not need to do that, but if you do, it really does help. It helps me. So that's the line. I need to find one perpendicular to it that crosses through this point. All right, let's deal with the fact it's perpendicular first. So I need to change the gradient. Now the gradient at the moment is -3. So that line is actually going to be a downhill line because it's got a gradient of -3. I want to find the perpendicular to that line. So I need to find the reciprocal. So I'm going to put -1, because that's what I do to find a perpendicular, over -3. Now I end up here with a double negative. So that means I end up with a positive third. Okay, so whatever my equation is, the equation of my line, it's going to be y equals a third of x and then plus c. I don't know what c is yet. If in doubt, I knew that above the c was 1, so I could put that down, but that's not how you need to go about it, okay? It's y equals a third of x plus c. So now I'm going to work out what c is, and then my equation's finished. So in order to find c, I need to know a value for x and y. And as if by coincidence, they've given me this coordinate point here, which tells me that it's got an x value of 6, and it's got a y value of 3. So I need to find the value of c when x is 6 and y is 3. So I'm going to substitute those values into my new equation here of the perpendicular line. So y equals, means 3 equals 1/3 of x, and x is 6. So it's 1/3 of 6 plus c, and that's what I'm trying to find. So I end up with 3 equals 1/3 of 6, so it's 6 divided by 3, which is 2, plus c. Now I want to get the c on its own, so I need to take 2 off both sides, leaving me with 1 equals c. So I know that c is 1. So I can now go ahead and plug that into my perpendicular equation. So y equals a third of x plus 1. And this was a 3-mark question. You get 1 mark for getting the gradient of the perpendicular line correct, so showing 1 over and then having the sense to manipulate the two negative signs. You get a 2nd mark for realising that you have to substitute in the x and or the y values, so 6 times a third plus c would get you your 2nd mark. And then your 3rd mark is for getting the whole thing correct once you've identified that that's a positive one. 3-mark question. Question 16 is asking us to rationalise the denominator, so they literally just want the root off the bottom of that denominator. So in order to do that, you need to multiply the denominator by root 5, but with fractions, what you do to the bottom, you must do to the top. So you're going to end up with 15 root 5 times by root 5 over root 5. So that will end up as 15 root 5 over 5, because the roots will cancel out. And then you can go ahead and do 15 divided by 5, which is going to give you 3. And then you've got the root 5. So you end up with 3 root 5. That's a 2-mark question. You get 1 mark for showing that you're multiplying by root 5 over root 5. And then you get an answer mark. You can leave it at that. You still get the answer mark for that, or you could go to that. If in doubt, leave it at that, because you still get the answer mark. Part B is expanding what will be double brackets. You can always have a go at this, don't ever leave it blank. We've got 1 plus root 3 squared can be written in the form of a plus b root 3, where a and b are integers, so they're whole numbers. Work out the value of a and the value of b. Now the fact that that is 1 plus root 3 squared means it's just 1 plus root 3, 1 plus root 3. So you can go ahead and expand these using the laws that we know about surds. So 1 times 1 is 1. 1 times root 3 is positive root 3. Root 3 times 1 is positive root 3. And root 3 times root 3 is positive 3. So once I've got to that stage, I can collect and simplify. So I've got that 1. I've got a root 3 and a root 3. So I've got plus 2 root 3. And then I've got that plus 3 on the end. I can then go ahead and collect, sorry, that doesn't belong on that one. I can then collect my numbers, so 1 plus 3 is 4 plus 2 root 3. So I've ended up now in the form of 4 plus 2 root 3. So A is the 4 and B is the 2. And that's a 2-mark question. You get 1 mark for expanding the bracket, and then you get the answer mark for stating A and B correctly. Question 17 is about simplifying algebraic fractions. They want you to write 3 over b plus 2 over a minus b as a single fraction in its simplest form. Now, they just want it as a single fraction in its simplest form, so don't try and overcomplicate this, okay? It's a 3-mark question. You always, always, always get 1 mark for showing that you're multiplying the denominators together. So I can write it as one big fraction out of b, open bracket, a minus b. Okay, I can write it as that. If I wanted to do it as 2 fractions, I could do that as well. So it's b, open bracket, a minus b, because I've times those 2 together. Now, I need to cross multiply so that a minus b gets multiplied by the 3. So the 3 was already there. It's now multiplied by a minus b. And that b can go up. It had a plus 2, and now it's been times by b, so it's plus 2b. So I can expand this bracket. 3 times a is 3a. 3 times b, or negative b, is negative 3b. And then I've got that plus 2b on the end. And that's all over. I'm not going to bother expanding that out. Okay, I'm just going to leave it as it is. It's b, open bracket, a minus b. I could do, there's nothing wrong with that, but I don't need to. I then collect my terms. I got 3a there, which is the only a. So I've got a negative 3b, add 2b. So that's going to be 3a, negative 3b, plus 2b leaves me with negative 1b over that common denominator. So the answer is 3a negative b over b, open bracket, a minus b. That's a 3-mark question. You would get 1 mark for showing that you've done the denominator, multiply the denominators together. You get another mark for getting cross-multiplying the denominators and showing any one of those steps. And then you get the final mark for getting that, or having 3a minus b over ba minus b squared. Doesn't matter. If you had the step in, because you like to keep them as 2 individual fractions, so if you just showed it as 2 fractions still being added together, so b open bracket a minus b, b open bracket a minus b, 3 open bracket a minus b, 2b, then that's fine. Okay, that step is the same as that step. I've just put mine together. All right, and that's the end.